I've only discussed this part. Did I discuss static routing with you guys? Yes, no, could be, might be. Does anyone remember where we stopped?
No, I don't remember.
Did we do the static routing? I don't think we did the static routing, right?
I don't think we did.
Yes, I think it was a static routing.
Where we stopped? Yeah. Okay. So let's just do static routing chapter. And I think I have the lab for it also done. Okay. I just want to make sure that if I have a lab here already configured for static routing. Yeah. Okay. Let's just do static routing today. So what is static routing? Static routing is basically when you are manually defining how the route should get to the destination. Like if I'm trying to send from point A to point B, I need to define which path to take. So in my lab example I created for my class is basically that I've got 3 sites, right? One is in Toronto, one is in Vancouver, and one is in Montreal. And I've got these networks sitting behind Montreal, 188, 188, 188.0/24, 200, 200, 200.0/24, 172, 168 is here, 192, 168 is here, and 158 and 179 network is here. So what static route does, it says, okay, if I need to get from here to here, what path should I be taking? So static means you are manually defining the path the route has to take in order to get to the destination. When I say a path for the network, these are the networks. When we say network, we are talking about the IP addressing over here. But you have to remember one thing. In routers, we don't define every single IP address. All we do, if you look at this, for example, executive in Montreal and Toronto, 158.2.2.2. The reason we have 2.2.2 is because I have assigned this PC this IP address. It's a /24. And what is a /24? When we were doing the IP addressing, I explained it to you guys. This is the subnet mask. And this subnet mask defines which part of the IP address belongs to the network and which part belongs to the host. So in my example here, the correct network address giving you a /24 is 158.2.2.0 /24, which is 255.255.255.0. So in this range, you're going to have 254 IP addresses. Understood? You can have 254 IP addresses. If you remember, if you recall the videos I made for IP addressing and how we calculate and everything, this is basically what this means. So in my router, I'm not going to be saying, okay, 158, 2.2.1 and .2, .3, all the way down to 254. I'm not going to be doing that. All I need to do on the network is I'm going to be defining this 158.2.2.0, 255.255.255.0. Router automatically knows that it has got 254 IP addresses sitting behind him. Understood, guys? So when this Vancouver wants to go to 158, the Vancouver, I have to define manually on it, saying in order for you to go to 158, you have to send your traffic to this Toronto. And if Toronto wants to come to the accounts team, which is 192.168.2.0/24, this will have to say, in order to get to this network, you have to go to this Vancouver. So you're manually assigning, you're manually configuring, basically, in order to get to the destination, what path or what is my next hop. So that's all they're trying to say. What is my next hop? So in order to get to 158, your next hop is Toronto. And for this Toronto, in order to get to 192, 168, you have to send it to Vancouver. Understood, guys? So that's what it all means basically. So let's look at the document. So this is, I give you a little briefing on how the static route works. Now let's look at this. This is called default static route. For the default static route means if I want to go to any destination, any 0.0.0.0 means any network, any destination network with a subnet mask of 0.0.0, with any subnet mask, I need to send it to my next hop, to wherever I want to go to. So that's what this is trying to tell you. Matches any network address, matches any subnet mask. Now my question is, in your home router, do you think that you have a static route defined like this?
No, sir.
Why? Why you think no?
Because there is a uh, kind of a preset routing table which they have to define in order to get the routing done, rather than giving an like unconditional table.
You see, the thing is that let's suppose you're sitting at your home, right? You're going to bbc.com, cnn.com, yahoo.com, right? Somebody else at your house, they want to go to some other Gmail, right? So your router at home, does he know all these addresses? It has to know that, okay, if any of my users sitting behind me wants to go to any of the network, because we don't know where the people of the house are going to be going to, which network, which website, right? So he doesn't know specifically which network basically the users are going to be going to. So what happens is basically we have a default static route set. Do not drop the packet, send it to some other router. So my router sitting at home, it has a default static route set for the Rogers or Bell or Telus, whoever you have got the internet connection with. He's going to be sending all the networks to those guys. And so you guys decide how to get to the destination. I don't know how to get to it. Understood?
So
Yes?
means that
Yep.
every out package is going to the your own ISP, and through the ISP is going to be sent forward
Exactly.
to the
Because you
destination.
see, your
Yeah.
websites, because if you look, let's go on the internet, how many web servers and web hostings are going on the internet? Millions and millions. Does my router at home know every single one of them? He doesn't, right? I'm trying to go to the Chinese web hosting server. So you think that my Rogers would know how to get to the Chinese one? I know how to get to the Chinese one. I would just bum 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 www dot whatever the thing is, right? The .com, right? So what happens is he doesn't know, but he doesn't drop it. Otherwise, if he starts to drop it, what would happen? The whole internet would crash, right? So he has to send it to somebody, and then that's somebody, that's some router on their Rogers or Bell. He has to basically decide whether he knows how to get to that server or not. Then he sends to some other router, they send to some other router, and then eventually it gets to the destination. Otherwise, if any of the routers in the middle starts to drop it, then the whole network will be basically, internet will be out of the window. Understood? So I'm not saying that all the way through
Uh,
static route. I'm not saying that, but I'm saying from your guys, from our router at home, yes, default is basically sending everything to that network. Yes, please go ahead.
Sayed Imtiaz, I have one question for you.
Please.
If I sitting in and I have so many customers, just just in Toronto, and then I have connections with them. I have to provide the service with them. Then every household has their own IP address, right? So based on that, how they define their network toward the customer? Are they what do you call it, creating VLANs for every section of the city? For example, this area should have these addresses, and every houses in that area are getting that specific IP addresses if there is free. Is that like this, or how they
Actually,
define the router?
actually, wait, I got half of your question because half of your voice wasn't, clear to me. But what I understood from
What?
your question
Yeah.
is you're trying to say is how does everybody on my street get an IP address or is it a VLAN, right? Is that what you're asking?
Now I'm asking. Well, this is my question, but from the ISP point of view.
Can you
If
type the
I'm sitting
question?
ISP, define how many? Excuse me.
Yeah, your
You're
voice is
actually
dropping.
your voice is breaking up, Wait. So can you type the question here?
Let me just try.
Sir, meanwhile, can I ask you one question, please?
No, I cannot type because the is disabled.
What is it?
Can I say?
You're breaking up, Wait, very bad, man.
Can you hear me?
I can hear you, but I mean it's like bits and pieces I can hear, but not the whole thing. While Wahid fixes his
The
voice.
problem is,
Yes.
yeah, the problem is I cannot even type because from your side is
Wahid,
chat is disabled.
type in Telegram, Wahid. I will post it for you. Type in Telegram.
Okay. So who else has a question? So Wahid is going to type in the Telegram, and then who else had a question?
Yeah, sir. My question was: is it possible to configure multiple VLANs on the same port,
In the same pod? What is a pod?
like on the switch port? For example, you have 24 ports on switch, so there's like T101, 1/0/1 or something, any port. Like, so is it possible on switch to configure multiple VLANs on the same port?
Yes, definitely. One second. On the switch port, you're saying?
Yes, sir.
No, on the switch port, basically, each switch port can have only one data VLAN and one voice VLAN. So if you look at this, I've got VLAN 10 assigned to this, and I've got VLAN 20 assigned to this fast03 port. But if I try to make a VLAN 40 or VLAN 30 or VLAN 50, this will disappear. So on each switch port, you can have two VLANs. One is for data and one is for voice. And punto, that's it. Understood? But over here, you can have the sub interfaces on the layer 3 device. Understood, guy? Yes, no, could be.
I'm sorry, sir. I missed the part. Even your sound was lagging as well. Can you please repeat the point?
What I'm saying is on the switch, you can have only one data VLAN and one voice VLAN. You cannot have two data VLANs on the same port.
Got it. So we
Understood?
can have like different types of ports can be configured on the same port, but it has to be like different kind of category, as in like data or voice or something else.
Data and voice VLAN you can configure under one port, but you cannot have two different data VLANs under one port. That's the whole thing.
Got it, sir. Thank you.
Okay. Let's
It's
see if
only
I,
those ports which are trunk port. They have multiple VLANs so that they can forward the VLANs to other switches.
that is a different story. That is for the trunk, right? That is for
Yes,
the
correct.
trunk.
Correct.
But for the data VLANs and for the voice, you can have this. Because if you look at this, fast01, what is this? This is a trunk port. And I explained to you guys, I very specifically remember, I explained to you guys that in order for a port to be a trunk port, you need to have a trunk port connecting to the router. The reason is, or connecting two switches together. The reason is, it's any traffic comes in with the tagging and encapsulation of VLAN 10, in this case, or a VLAN 20, it is going to forward it. If you don't have a trunk port going to the router or going to a different switch, if when two switches are connected, then if you do not make it a trunk port, then the traffic tagged or encapsulated means attachment with a different VLAN number would not be able to go across. Understood? So that's what trunk does, take traffic from different VLANs. But assigning VLANs under an interface can have only two, one data and one voice. Okay?
Yes, sir.
So basically in this case, what I'm saying is IP route 0.0.0.0, any destination network, any destination subnet mask, you send it to the next hop IP address. I'm going to show you how I did it in the lab, then you guys can practice. Uh,
I
so
would
what
suggest if you can show them the web page where they can download the packet tracer, because I don't think these people would have downloaded packet tracer on their
I asked
own.
3-4 times for you guys to download
Yeah.
the packet tracer. I didn't get any reply back saying, I'm
No,
having problems.
I don't, I don't think that these guys would have downloaded packet tracer and they would have
Have you guys
understood what it.
downloaded the packet tracer, guys? I know 2 people said they have downloaded it. They have it. Anybody else basically downloaded it?
I have downloaded a long time ago. I even sent the YouTube download, and even there were training, so I can try to go around with the packet tracing.
Okay, if you can share that link with these everybody, I'll appreciate it. Wait. Otherwise, I'll see where I can download this. I can share it. Okay. So in this, if you look at this closely, this is the format. IP route my packet to the destination network. How? Through a next hop IP address or my exit interface name. So now when if I show you guys this, is basically, which the static route lab is this one. If I show you this, and if I do a show run on it, now look at this. What I'm saying is IP route, my going to any destination network, going to any destination subnet mask, and this is my next hop IP address. This is the next hop IP address. What is this next hop IP address? If you look at this, this is the interface for my next hop. From here, I'm saying send all my traffic going to anywhere to this interface right here. Because if you look at this 175, 175, 175.1 is this interface. 175, 175, 175.2 is this interface. Why? Because this is a /30. And if you have if you look at my videos, I explained this. If you have a /30, which means you can have only 2 usable IP address. So one you use for this one, and the other one you can use on the other end. So this IP route is saying going to any destination network, any destination subnet mask, simply send the traffic to this interface and punto. That's it. This is all static route is. Or, or the other way of doing it is you complete this and then saying instead of the next hop IP, use your own exit interface name. When I say my own, if I am in the Vancouver, then whatever the name of this interface is, I'm going to have to write it down here. So if you look at this serial 00, this is the one which connects to my Toronto router. So what is my own exit interface name? Serial 0/0. So I'll be putting it serial 0/0 over here. Understood, guys? So there are two ways: the next hop IP, which is this one, or your own exit interface. So this, now, can I put, now I explained the default static route. Now, if I am in Toronto, can I put IP route 0.0, the default static route? Can I put it here? And going, if you're looking at this network connectivity the way it is here, if I put this default static route here, would I be able to communicate with the Vancouver and the Montreal networks or not? By just looking at this diagram, I've got an office in Toronto, I got an office in Vancouver, and I got an office in Montreal. Just understand the logic. My whole thing is understand the logic, then you can, once you have the logic, then you can build on top of it, right? So in my example, what I gave you the default static route, I explained this default static route. Now, if you look at this diagram, can I put default static route in Toronto and then be able to communicate with Montreal and Vancouver both?
Is the picture too small for you guys? Are you able to see, understand what is happening?
Yeah, I think it's big enough, Joey. I think it's big
Nobody is
enough.
buying anything.
I'm sorry?
Almas, Ahmad, anybody?
Are you guys are sleeping today or what? Okay.
So, as
Yes.
what I understand, either we can like provide the IP address of the next router, or we can provide the connection, the serial connection where the traffic is going outside from the router.
That's perfect. That's good that you understood that point. But my point is, if I put a default static route on Toronto, would I be
Mhm.
able to communicate with Vancouver and Montreal sites both or not?
What I'm assuming is no. We can only through static route it can only communicate to either Montreal or Vancouver,
Why?
because we are only providing the either the port number, which is like uh, transferring the data to the other hop, or the
You
IP address
cannot
of
say
the.
you cannot say static route. You can have to be a default static route. The default static route means 0.0. Default means any network, right? So in this scenario, if you point your default static route to this Vancouver, then how the traffic is going to go from here, from executive PC to IT department? Rhonda is going to say, well, I got a default static route pointing to this. So he's going to send everything to this Vancouver. But this 188 is not sitting in Vancouver, it's sitting in Montreal, right? So in this scenario, when you have two connections to two different routers, the default static route would not work, right? Your static route would work, but your default static route would not work. So that's why in Toronto, you have to specifically define that in order to get to this network, accounts team in Vancouver, my next hop is this IP. In order to get to the marketing, my next hop is the Vancouver IP address. In order to get to the Montreal, my next hop is this IP address right here because I wrote 199.199.199.1 and .2 because it's a /30. You can have only two usable IP address. And 200.200.0, 199.199.199.2, which is Montreal. So I'm specifically defining these networks. I cannot put a default static route here. Otherwise, I will have to say send everything to Vancouver. But in reality, these networks are not sitting behind Vancouver. These networks are sitting behind Montreal. Understood? But from
Yep.
Montreal, there is only one link out, one way out. From here, you can put a default static route pointing to Toronto from Montreal and also from Vancouver to Toronto. So that's what they're just trying to tell you here also. IP route 172.16.10. This is the subnet mask. And next hop is this IP address over here, from here to here. Okay. When to use? When it's a small network, yes, that's the time when you guys use it, because once you have like 20, 30, 40 routers, then it becomes very tough to handle and manage the static routes. That's where the routing protocols comes in, the dynamic routing protocols we call. So once we hit the Ospf chapter, then we're going to be looking at it. But in the small network, it's fine. And this is called a stub network. The reason stub network is because only one way out. Only one way out, you can get to the destination. So that's why it's called stub, isolated. So there are four different things. Standard static, I showed you the standard static, how this is the standard static right here. Each network, next hop IP. Default static, I showed you the default static, IP route 0.0.0, 0.0.0, any network, any destination subnet mask. Summary static route. Summary static route is what? Basically, you're changing the subnet mask, so you're getting a bigger range. So we're going to see that. And floating static route is what? Floating static route is when you're using and manipulating the administrative distance. We're going to be looking at that. So basically, this is just an example. No need to use a dynamic routing protocol with R1 between these two, because there is only one connection out of here. Simply use one static, and that's you're out of here. And this is the default static. We saw it earlier. I show you the example, zero, any network, any destination, because you see this is going to the internet. And you don't know where each individual person is going to be going on the internet, right? So that's why just simply send it to the internet and let the basically ISP manage it and make sure that you get to the destination the way you're supposed to. Otherwise, if the ISP doesn't know, which means what? The internet is not working. This is another example, the summary static route. So look at this one closely. IP route. IP route means in order to get to this network, this is my next hop. In order to get to 172.20, 0.0, 255, 21, 22, and 23, simply send it to my next hop from R1 to R2, right? Now, what they did here, rather than putting four lines here, you simply put IP route 172.20, and instead of 255.255, you dot 255.252, and then this, if you find, you have, I'm not sure how many people have gone in and looked at the video for my IP addressing. You guys will have to go in and calculate this range 172.20. If you calculate this 172.20 range, given this subnet mask, you're going to see, you're going to have in this range 172.20, 172.21, 172.22, and 172.23. Everything is going to be in this range right here. All these networks are going to be part of this one liner right here. So use the formula I gave it to you and you calculate this. So you don't have to basically write every single line here. You simply put this and it will cover all these networks right here. So this is called summary static route. You're manipulating the subnet mask in order to in order to summarize it. Because remember class A, class B, and class C? This is what? This is a class B, right? So class B, the default subnet mask is what? 255.255.0.0. But you are reducing the subnet mask, right? You're changing the subnet mask. So that's why it will become as a summary static route. So if you calculate this range, you're going to see that .20, .21, .22, and .23, everything is going to be under this line right here. So the router, as soon as you put it on the router, he will know right away that in order to get to any of these networks, I can simply send the traffic to this guy and punto. That's it. I'm done. All these networks are going to be part of this one-liner. So go and watch the video, see how I calculated it, and then do it and practice it like this. So this is called summary static route. What is a floating static route? What floating static route is, every routing protocol has an administrative distance costing. Let me see if I have the costing here or not. Uh, did it, did it. Okay, I don't have the routing protocol costing here defined, but I think it's defined somewhere. I've defined it, right? So I'm gonna have to check on that. So what this is, static route. Let me see if I can find it on the internet. If you do administrative distance of routing protocols, let me see. Here we go. This is this. Anything static route, let me give an example. If I'm learning a network through static route, my administrative distance is 1. If I'm learning it through Ospf, my administrative distance is 110. What this simply administrative distance mean is the lower the number, the more preferred the path, the more trustable this path is. So that's why in the networking, what they have defined, every single routing protocol, they have given administrative distance like this. If you're learning about a network through static, it's 1. And 1 is more trustable than OSPF. Understood? So this 1 is more, because the lower the number, the more trustable that routing source is, they're saying. It could be static, it could be OSPF, it could be BGP, it could be EIGRP, it could be ISIS, it could be anything. So this floating static route says, because my administrative distance is 1, I will try to manipulate and make it, let's suppose I make it 150. So if I make it 150, my OSPF is 110, which one will be more preferred? OSPF, right? Because OSPF administrative distance is lower, is 110. Otherwise, if I don't change it, what would happen is I'm going to learn everything through static. And because by default, the static route administrative distance is 1. So the floating static routes or static routes used to provide a backup path to the primary static or dynamic route in the event of a link failure. So let's suppose you're on the branch office or you're on the headquarter and you're trying to get to the ISP. So basically, there are two ways of going to the internet. Either you go from headquarters to this one, or you go from branch to this connection, or you go from a private WAN and then you send all the traffic to the headquarters, and then from there you can go to the ISP if this connection is down. So basically, we will have to define, okay, in our design, which path should I take? Should I take this path like this and then go to the internet? Or should I just simply take this path and go directly to the internet? Understood? If I have designed it in a way that all my internet traffic would be going from here to the headquarters or going from branch to the ISP, then I have to manipulate. If this connection goes down, then I should have a backup path to the headquarters, and then from there I go to the ISP. You guys understood this point, guys? Yes, no, could be, might be, or lost.
Yeah, yeah.
Okay, that's good. So this is how you change it. Because otherwise, if I put a static route, What is the administrative distance? 1, but I'm making it 100. And the reason I'm making it 100, because they're saying the EIGRP administrative distance is 90. So if I make it 100, which means my friend only use my EIGRP as my primary, and my backup is basically my static route. Otherwise, if I don't put 100 here, what would happen is because the static route admin distance is 1, I will prefer that path at all the time. So that's how we change and manipulate this floating route by changing the numbers. So we make sure that the path is taken the way we want the traffic to be going. Okay. Route summarization, I just explained it to you guys. If you calculate this, you're gonna you're gonna have 20, 172.20, 172.21, 172.22, 172.23. So you guys can do this calculation. Use the magic number 256 minus 252. It's 4, and this is a completely divisible. So what would happen? You start from here, and you end it to 172.24. That's a new network. So anything with one between 20 and 23 is your range. So this is basically called summary routing. You're covering, rather than putting every single static route, 4 static routes here, you're just putting one of them and then you're covering it. And you're changing the subnet mask as per the classful behaviors. The classful behavior for 172 is what? 255.255.0.0, but you're reducing it in order to cover a lot more networks. This is the command show IP route. This is the same example I was showing you in my in this lab. You got this network sitting, you got this network sitting, you got this network sitting. And I said you can put a default static route from R1 towards R2, R3 towards R2, because why? There is only one way out of it. But you cannot put default static route 0.0.0.0 on R2 because you have to point it to somewhere. If you point it to R1, then you'll be able to get to 172.16, but you will not be able to get to 190.168. So if you have got only one way out, yes, sure, put a default static route 0.0. But if you have got 2 connections going out, then it is a problem. Then you have to basically specifically define in order to get to 192.168, you got to send it to R3. And my friend, if you want to go to 172.16.3, then you have to send it to R1. That's the whole logic, and that's the whole basically criteria for these static routes. They're doing the calculation for you, but I've showed you guys a shortcut of doing it. So you just use that way. This is IPv6, the routing table. Is basically, remember IPv6 when I explained it to you guys said there is a 314, right? Everything is hexed. It's 16-bit, 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 16-bit. Everything has 8 hexed, and each hexed is 16-bit. So that's what they're saying. This is the 314 because we are not doing subnetting of these IPv6 because each human on this earth, as I mentioned it when I was explaining IPv6, is each human in this earth can have millions and millions and millions of IPv6 addresses. So imagine how big this is undecillion they're saying. So this is basically your network portion. This is your subnet portion, and then you can give your ISAN IP address. And colon means what? That there is a continuation of having 0.00, sorry, 0.000.0.0.0.0. So you can only use one time in your IPv6 addressing, right? Go and look at the video for that. You will have it. So they're saying identify the address differ. These are all the basically your subnets. So you can have 0001, 0002, 0003, 0004. These are basically, defining all the networks with this, because why? They're taking the leading zeros. Remember that? They're taking the leading zeros out of it because when the computer sees it, he sees this, and he knows right away that there were 3 zeros before 1. There were 3 zeros before 2. There were 3 zeros before 3. Understood? So this is they just have this in a in a hex format. You remember? Every single bit is basic. Every single zero is what? These are hex, right? 4-bit, 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 and 4-bit. That's how it becomes 16. So if you look at this 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Remember IPv6, guys? Each is 16-bit. Each hexet is 16-bit. So basically, this is all hex, right? So this 1 0 means what? This is basically 4 zeros here. Then this is again 4 zeros here. Then again, this is 4 zeros here. Then again, this is 4 zeros. But this is the subnet mask 0, 0, 0, 1. So this is the whole, because you see all of these are hex, right? Remember, I showed you guys hex to binary, and then from binary to hex conversion and decimal conversion. And remember, I said you need this when you're looking at this. So this A is basically got 4 bits in it. The C is 4 bits. And anything from 0 to 9 in decimal to hex is exactly the same. The only difference is once it starts to go from 10 to 15, 10 is A, B, C, D, E, F, and punto. That's it, you're done. Right? So this A is 15. Understood? So basically, all you're doing is, you've got 1, 2, this is 3, and this is 4. 1, 2, 4, 8. So you got this 4. So they're saying all the matching zeros are basically 13 bits. So you got 1, 2, 3, 4, 4, 1, 2, 3, 4, 8, 9, 10, 11, 12, 13. These are 13 bits. So if you add it up, it becomes 61. So this covers your subnet 1, subnet 2, subnet 3, and subnet 4. That's all it does. So if you put 61, it will cover the whole range 1, 2, 3, and 4. So that's why I just explained to you here how they're doing it. So either you do this, same concept. The only difference is your IP route. Over in IPv6, you're doing IPv6 route. There is no other difference, right? And this is the next hop IP, whatever the IP of the next interface is. So summary route is what I just showed you here how to do it. 61. If you use the 61 IP route, IPv6 route 2001 DB8 ACAD:/61, this basically covers all these 1, 2, 3, and 4. It covers all that, and this is right here. I just explained how it covers all that. Ospf. Now, Ospf is basically what you call it. This is also a routing protocol. And how we configure Ospf, this is the most used Ospf. And Ospf is a classless. Classless means that it takes the subnet mask also to the networks. So how we look at this is secure, classless, efficient, fast convergence means that if something has gone down, it will remove it from its routing table, because all the routers, they make the decision based on the routing table. If it's not there, then it will simply remove it. Scalable is expandable, when you can add more stuff in it. So we'll look at it. So just look at it this way. I'm not going to give you the formula. It's a pretty long formula for OSPF. Just look at it this way. What OSPF does, it looks at the cost. It works on a cost. And how the cost gets determined is basically what the type of bandwidth this is. It has got more, the higher the bandwidth, the lower the cost. Remember that. Higher the bandwidth, lower the cost. So if this is basically, let's suppose 5 meg, this is 5 meg, this is 5 meg, and this is 100 meg. So you tell me if this is 555 and this is 100, So this is the cost is going to be lower. So remember, higher the cost, higher the bandwidth, lower the cost. And once it's lower the cost, OSPF prefers that path. OSPF says, I'm going to be taking this path to get to the destination. So if you have got these routers connected like this, and if, let's suppose if R2 wants to go to R3, and these are all the cost, is it feasible for him to go from 20 cost, 40, and 10 is basically 50 and 252? Or it goes from R2 to R1, like 20. This is cost is 5. And then this 2. This is 27. So which path will it prefer? Or it will take this path, R2 to R5, R5 to R4, R4 to R3, and then this. So 10, 20, 30, 32. So if you look at it, all these costs, when it adds up, it's higher. Then the more preferred the path is basically from R2 to R1 and from R1 to R3. Understood, guys? So this is just showing you. So if you're sitting on R2 LAN, which is right here, R1 to R2 is basically 20 like this and 22, right? R3 LAN, which is this one, which one is the shortest? He's going to jump directly to R3 because this is 5 and this is 2, it's 7. If it tries to go from here to here, this is 30, 20 plus 10 plus 2, 32. So the OSPF says, I'm going to be taking the cost which is lower. So it selects basically this path. So that's what they're trying to show you here. Creates areas. So remember, OSPF work on areas. It just works on areas. Area 0 is considered to be the backbone area. You can connect. In order for area 51 to go to area 1, you have to go to area 0. In each area in OSPF, you can have not more than 50, theoretically, right? Not more than 50. But in practically, we don't have 50 routers in one area. Maybe go maximum 15, 20, whatever that is. Because you see, everyone has to calculate that in order to get to the destination, what is my cost? What is my bandwidth? What is my delay? How much load this connection has? And then OSPF decides on that. So that's why we don't put too much, but they have Cisco and all these Juniper and all these other vendors, they have put a threshold of 50 routers, not more than that in one area. But area 0 is considered to be the backbone area. And any area, if it wants to connect to the other area, that area 1, then simply it will have to be sending it through area 0 to bypass it in order to connect. You cannot connect two areas together without going through area 0. Understood? You don't have to worry about these. This is all encapsulation. OSPF packet type, it just says hello. Are you somebody's out there? If you are configured OSPF, it says hello, are you there? Am I connected to the OSPF? The other end replies back, yes, I'm also part of the OSPF. And then there is a handshake, just like TCP, there is a handshake. Remember I was explaining TCP to you guys, the transmission control protocol. What it does, it's a handshake, it's a synchronization. Okay, I'm here, you're there, I'm going to be sending you traffic, I need an acknowledgement. In the TCP protocol, what happens is basically he expects an acknowledgement, right? Remember the TCP chapter? So they basically expect an acknowledgement. So that's what this hello packets and OSPF packet types are. They send it to each other, and then they send an acknowledgement, and then they start to send each other's network to each other and saying these are the networks sending behind me. The other guy sends his networks, and that's how they know. You don't have to specifically define how to get to the destination. So for example, if you look at this OSPF lab I made, and all you do simply is do this. Running config. Now, if you look at this, what I have configured is this. These are all my inter-VLAN routing. This is my 158.2.2 network, my 129, my 175, 199, and my loopback. Loopback is a virtual interface. It never goes down. So I said my router ID is 20.20.20.1, which means that this is my name. Router ID means it's a ring, it's a name. And you only define these network statements rather than saying IP route this and IP route that. You simply says network 158.2.2.0. It's a wildcard mask, guys. I explained the wildcard mask. What is it? It's the reverse of a subnet mask. If you have 255.255.255.0, the reverse of it is 0.0.0.255 and area 0, which means what area I'm in, I have to be in area 0. If the other ends are in area 1, then it will not be communicating with each other. So you have to be in a single area for the routers to communicate with each other. Understood? So all you are advertising by putting a network statement in it, saying that these are the networks sitting behind me, the Toronto, and then I'm going to be advertising these networks to my neighbor. So Toronto is going to be advertising this to Vancouver, and Toronto is going to be advertising this to Montreal. That these are the networks sitting behind me. That's it. You don't have to statically define the static routes saying IP route, this network, this subnet mask, next hop. You don't have to do any of that. You simply to explain, you simply put the network statements by saying that these are the network basically sitting behind me, and that's it. And then they will send each other the whole table. They will exchange the information with each other.
Same.
Sure.
I have a question.
Mhm.
You in your configuration networks, which one are they? I mean,
I'm sorry.
you have three routers here. Yes, in Toronto.
Give me a second. Let me bring it up. This one? This one?
Yes, in the net.
Wait, your voice is
In
not coming through, man.
Toronto, you define.
I cannot hear you, Wade. Is there a way for you to type? This message is for sitting in ISP and I have customers around the city in Toronto. How do I configure the router switches to assign? Okay, I'll come back to this one. Wait, I cannot understand you, my friend. So if you can type, just let me know.
No, he's somehow he has not registered in a proper way, so he's unable to type. And I think his internet connection is
Yeah.
choppy. Some problem.
Wait, if you can type, then I'll explain both the questions you have. Right. So this is what the Ospf type is. You don't have to worry about these. This is I've just put it in. If you want to get into more detail, what the packet looks like. Ospf packet looks like. So you don't want to get into the packet format and everything. So there is something called hello and dead interval. What hello and dead interval means, if I'm in Ospf and my other router is also in Ospf, so let's take this example. My Toronto is Ospf and my Vancouver is Ospf. So I'll be sending hello after every 5 seconds, right? Just to make sure that the connection is up or not. I'll be pinging that IP, I'll be sending hello to the other end, and the other end has to reply back to me after 5 seconds. In 5 seconds intervals, I'll be sending hello and I will be expecting a reply back. Dead interval is 3 times or 4 times, depending on how you want to configure it. Is basically if I don't, let's suppose if I make it the 4 times my hello interval. So my hello interval is what? Is 5 seconds. So my dead interval is what? If I make it 4 times, 4 5 is 20, 20 seconds. So if I send 3 or 4 packets and I do not get a reply back, only at that time I'll say my connection is dead. Because sometimes what happens, the connections, starts to flap. And once they start to flap, and what will happen is, OSPF will be flushing everything out in its database and its routing table. And then the route, once the connection comes up, it's going to recreate everything. So we want to give it a space to 4 times the hello. That, my friend, if you missed one hello or two hellos and if you're not replied to it, then at least wait the 4 times the hello interval and then flush everything out. Do not flush everything out right away. Do not announce it to your neighbor saying, hey, you know what, my connection is down. Understood? That's what this hello and dead interval is. So basically they're saying that a frame relay, nobody's using frame relay anymore. Why? Because this is only 1.24 meg. And who's using 1.2425 meg, right? Even in the homes, you're using 200, 300 meg. So basically, we ourselves can set up the hello, and we ourselves can basically change the dead interval also at the same time. Electing DR and B. This is designated router and the backup designated router. If the routers are connected on in a switch like this environment, this one guy, he basically, what the designated router does, he says, you know what? If any of your connection fails, you do not have to announce it to each other. You simply send it to me, and then I will let others know if a connection is lost or a network is not out there. I'll just simply, flush before flushing it out, announce it to me, let me know, and then I'll announce it to everybody else. That's what designated router does. It's election which happens, and it says, rather than you guys communicating on what network is up, what network is down, and doing all these calculations, do not get into it. Your job is just to basically get the traffic, send the traffic out, get the traffic, send the traffic out. Let me worry about it. Let me take the role of the designated router. You know anything of any changes, any network going down, any networks not in your routing table anymore, you send it to me and then I'll announce it to other routers so that you guys can be busy with your other traffic, legit traffic going out and coming in. Okay? Because you see these routing protocols are very processor intensive, memory intensive. You see all this calculation going OSPF is doing. So router has to do what? Router has to do the use the memory. Router has to use the processor, right? Every, like, even in PC, what happens? If you got too many things going on and you don't have enough memory or a processor speed, what will happen? It will slow things down. So the same thing comes into the basically routers. Okay. Don't worry about these. Here you go. This is what we were looking at, looking for when I went on Google as administrative distance. This is what the administrative distance is right here. The table on 159. There is also an authentication. You can configure authentication. What authentication does, it says, okay, my friend, if you're OSPF, I'm OSPF, and this is OSPF, all these three routers are OSPF, then we can configure password. If the password matches on both routers, then basically create a connection between these two routers. Otherwise, don't create a connection. If R1 and R3 is basically an OSPF and basically they have the password match, then create a connection, otherwise don't. So the reason we do it is because, we don't want any, Tom, Dick, and Harry bring a router and connect it to the network and say, here you go, let's have fun. Right? So just to make it more secure. That's what. Basically, these are just the state, the down state, initial. Like when your system comes up and your router comes up, it's in the down state. It initialized the OSPF. It's a two-way state when the connection goes on. starts to handshake,